In the last class, what we have discussed is we discussed what is electric, what is charge, what is the charge of neutron, what is the charge of proton, what is the charge of electron, okay, and what is electric current, what is the unit of electric current, it's ampere, how we can define an ampere, what is a equation to find out the electric current, I is equal to Q by T, okay. So all these things we discussed, right? Now, in today's class, what we are going to discuss is we are going to discuss the term potential difference. Okay, no need to write, just listen. We need to discuss the concept potential difference. Okay, so what makes electric charges flow? That you know, right? What makes electric charges flow? Any idea? Electric circuit, you may, I think we discussed, right? What is the electric circuit? What are the different components? What is the main component? Battery, right? So the battery is providing the energy for the electrons to move throughout the circuit, right? But what makes in the battery, okay, what makes the battery to push the electrons in such a way that it will circulate through the circuit? What it is? So that is potential difference, right? So if we want to walk, we need certain amount of energy, right? So no, no. Suppose we want to walk, right? If we are not eating anything for a long, for 1 week or 2 weeks, we cannot walk, right? We cannot speak. We will be tired, right? So we need certain amount of energy. That energy is provided by through a food, that the food that we are eating, right? Similar way for for the car, motor vehicles, we need petrol, diesel, right? It's a kind of energy. This petrol and diesel, that fuel is giving the energy for the motors to the vehicles to move, right? Similarly, these electrons, if they want to move throughout a circuit, okay, they also require certain amount of energy. So that energy is provided by the battery, okay, and through certain potential difference. So what is a potential difference? It is nothing but it is something related to energy. Got it? It is something related to energy. But we need to define it, right? We need to define it. Then only we can calculate potential difference, right? So what is potential difference? See, it is nothing but, listen carefully, okay? So electric potential difference between 2 points. 2 points is what? Battery we have positive terminal and negative terminal. These are the two terminals. Okay. Potential difference comes where? The battery. Okay. Let me draw it. Okay. This is a resistor. I'm just current direction from positive terminal to negative terminal. Okay. This is the current. So what makes the electron flow? Electron flow is the current, right? What makes the electron flow? So that is the potential difference between the 2 points. Which are the 2 points? These are the 2 points, positive terminal and negative terminal. Okay. So electric potential between these 2 points in an electric circuit carrying some current is defined as the work done to move a unit charge from one point to other. What it means? First, tell me what is unit charge? What do you mean by unit time? That you know, right? What do you mean by unit time, Lakshminanda? Unit time. When we discuss electric current, we define electric current as the amount of charge flowing through a cross section in unit time or in 1 second. Unit time is 1 second, right? Similarly, unit charge means what? Unit charge means what? What is the unit of charge? What is the unit of charge?
Column.
Coulomb. Okay. So unit of time is second. So unit time means it will take normally it is 1 second. Similarly, the unit of charge is coulomb. So unit charge means it is nothing but 1 coulomb. Okay. So work done to move a unit charge from one point, that is here one point I am taking, it is a positive terminal, to other terminal, that is negative. Just read that statement again. I explain what do you mean by unit charge. I explain which are the 2 points. Okay. Just read that statement and try to understand what exact. And you have to give me an equation from this definition. You have to give me an equation. So if you are able to give an equation for this definition, then you understood that properly. Do you get any idea, Anuvit?
So, work done is joule and
Work
coulomb.
done. Okay.
Charge is coulomb.
Okay. Work done. The unit of work done is what? We will explain in Joule.
Joule.
Okay. Okay. Then unit charge is 1 coulomb.
Coulomb.
Okay. Then explain in your
So,
own words what you understood from this statement.
so how many joules are required to
Hmm.
move 1 coulomb of charge through the circuit?
Yes. That means it is the amount of work done to move 1 coulomb charge from this positive terminal, this point to this point, negative terminal. 1 coulomb charge. See what is electric current? It is nothing but it's the movement of charge. Okay. So we are taking unit charge, that is 1 coulomb. So if I want to move 1 coulomb of charge from this positive terminal to this negative terminal, I need to provide some energy, right? So here, who is giving the energy? Who is giving the energy?
battery,
Battery or the cell, right? Battery and cell are different. Okay. So cell, it's actually a cell. There will be multiple cells in a battery like this. Okay. So this is a battery. Okay. This is a cell, but you can use battery also, no problem. But specifically, if some question comes, so this is a cell and this is a battery. Okay. Battery is a combination of multiple, more than one cells. Okay. Let me explain. So for moving 1 coulomb of charge, I am going to move the 1 coulomb of charge from the positive terminal to negative terminal, and I need an amount of energy, or I need to do a certain amount of work. That is called as what? Okay, let me explain once again. So electric potential difference between these 2 points in an electric circuit which is carrying current is defined as what? It is the work done to move unit charge or 1 coulomb charge from one point to another. Okay, unit charge or 1 coulomb charge to move from one point to another. Clearly understand the concept. Now I am going to ask the question. If you are not understood, please let me please clarify it. Please clarify it. Okay. So I am going to give a real time situation. Okay. See, I am going to move q amount of charge. Let me erase all these things. I am going to move q amount of charge. What's q amount of charge from this positive terminal to the negative terminal? Q amount of charge or q coulomb of charge. And the work done to move q amount of charge from this positive terminal to negative terminal is W. What is the total charge I am moving from positive terminal to negative terminal?
Q.
Q coulomb or Q amount of charge. Okay. And what is the amount of work that the battery is doing, or the amount of energy the battery is supplying is what?
W.
W. Now, find out what is the potential difference. If you're telling, I know you know the equation. If you already covered in your schools, you may be knowing the equation. But if you are telling the equation, you have to tell me how it comes. Same way, just think about the definition of electric current and how we derive the equation for electric current. I is equal to Q by T. Same way, from the definition of potential difference, you can derive the equation. So why I am taking like this means now. So if you understood how this equation comes, you will never forget this. That's why. Got it? What will be the equation? This is Q amount of charge the battery is providing or doing, W amount of work or W amount of energy or W joule of energy. Now, I'm just what we need to find out. We need to find out what potential difference. I'm just writing potential difference which is equal to V. Okay. Now you just read the definition. What is potential difference? Anybody got the answer? Equation? Read that statement. What is the potential difference? It is the amount of work done to move unit charge, right? From positive to negative terminal or from one point to another, right? For 1 coulomb charge, what is the amount of work required? That is potential difference, right? Here I am moving Q amount of charge and I am spending or the battery is spending W amount of work, W joule of work. Then from that find out what will be the amount of work required to move 1 coulomb charge. That is the potential difference. Story of mango. 10 mango cost 100 rupees. 1 mango. How much? How you will find? Same way we derived the equation for electric current, right? Find out. Q amount of charge. The amount of work done is W. So 1 coulomb of charge. What will be the amount of work? That is potential difference, right? 1 coulomb into W. That is W by Q. Simple. Okay. By definition, the potential difference between these 2 points is what? It is the amount of work done to move unit charge. That is 1 coulomb charge. But here, what? How much charge I am moving? Q coulomb of charge. I am moving from positive terminal to negative terminal, and the battery is spending W joule or W amount of work for that. From that, find out what is the amount of energy or amount of work required for moving 1 coulomb charge. That is simple mathematics. W by Q. Got it? All of you?
Yes, sir.
Gopika, Anuvind,
Yes.
Gopika, clear?
Yes, sir.
So what is the equation
Yes, sir.
for potential difference?
Work done by charge.
Is equal to W by Q. Okay? V is equal to W by
Amount of
Q.
charge.
How we derive that equation? From the definition only. Okay? Here Q is the total amount of charge flowing from one point to another, and the work or the energy, both are same. Spent for that is W. So W by Q is the potential difference, that is V. Okay. So what do you have to understand? What do you have to get from this? What is potential difference? Okay. And how we are coming to this equation. V is equal to W by Q is the equation for potential difference. Okay. That you can remember these two things. But how we coming to this equation, that is also important, because if some twisted question asked, if this step is clear, any type of questions you will be able to answer related to this. Any type of question, any twisted type of question based on potential difference, you will be able to answer if you understood this step. How this equation comes, V is equal to, fine. Now come back to the just rewind electric current. We studied definition of electric current. We derived I is equal to Q by T, right? And we found the equation. Oh, sorry, we found the formula. Sorry, we found the unit. What is the unit of electric current? What is the unit of electric
Ampere.
current? Ampere.
Ampere.
That is equal to I is equal to Q by T, which is equal to 1 coulomb by 1 second, which is equal to 1 ampere. Similarly, the unit of potential difference is unit of, not simple potential difference, unit of electric potential difference is volt. Unit of electric potential difference is volt. Okay, so how we will, what do you mean by 1 volt? You should understand, right? You know what you mean by 1 meter, right? You will get some kind of visualization, right? If someone is saying that 100 meter or 1 kilometer, you will get some kind of visualization, right? Or 1 meter, this much distance, you know, right? So no. Similarly, when someone saying 1 ampere current, you should able to understand what exactly it is. What do you mean by 1 ampere current? If, what do you mean by 1 ampere current? Hazel, any idea? Any idea? Devaganga, what is 1 ampere current? If I'm saying that the current flowing is 1 ampere, what exactly, what kind of visualization you're getting?
So 1 coulomb charge passing in 1 second.
Very good. That means 1 coulomb in that circuit. At any point, if I'm measuring the amount of charge flowing in 1 second is 1 coulomb. So that is a visualization. Similarly, what is 1 volt? If I'm saying that the potential difference between these two terminal of a battery is 1 volt, what it means? Nothing. We have to, from the equation, simple. We know V is equal to what? W by Q. W is what? 1 joule. Coulomb. 1 joule by 1 coulomb is equal to 1 volt. So what exactly it is? 1 joule by 1 coulomb is equal to 1 volt. My handwriting is too bad. Let me write here. So V is equal to W by Q. So W, the unit of work or energy is joule. So I'm just writing 1 joule by 1 coulomb, which is equal to 1 volt. 1 joule by 1 coulomb is equal to a potential difference of 1 volt. What exactly it is? What it means? Make it in a statement. If I'm saying that the potential difference is 1 volt, you know it is 1 joule by 1 coulomb. But give me a statement like 1 ampere. And can you give? I'm saying that the potential difference between two terminals or 2 points is 1 volt. What exactly it is giving?
So 1 joule energy is needed
Hmm.
to
Hmm.
move 1 coulomb of charge.
From
Uh,
one point to another. Simple. Okay. If I'm saying that the potential difference between 2 points A and B is 1 volt, here it is 1 volt, means the energy required to move 1 coulomb charge from here to here, it is 1 joule. If I want to move 1 coulomb of charge from point A to point B, is, sorry, 1 joule of work or 1 joule of energy is required to move 1 coulomb of charge, then we can say the potential difference between the 2 points is 1. Okay, Clear? What do you mean by
Sir,
1 volt? Yeah.
sir, can I move the class?
Yes. I'll record it.
Yeah, please. Thank you.
Understood? You have to study in that order. First, you have to study what is potential difference. Definition. Okay. So from the definition, if you understood the definition properly, you will able to derive the equation V is equal to W by Q. Okay. V is equal to W by Q. From that equation, you have to find out what is the what do you call the unit. It is 1 joule by 1 coulomb or joule by coulomb. It's the unit of potential difference from the equation. But that is very lengthy. So instead of joule by coulomb, we are just representing volt. That's it. Simple. Like your ampere. Ampere is what? Q by T. That is Q by, sorry, coulomb by 1 coulomb by 1 second. So here it is 1 joule by 1 coulomb is equal to 1 volt. So that means from that equation, what it means, if the amount of work done to move 1 coulomb of charge or unit charge from one point to another is 1 joule, then we can say that the potential difference is. Okay, got it? So what is
Yes, sir.
potential difference? Yes, someone said something. Okay. So what is potential difference? You understand how this equation comes. V is equal to W. From that equation, what is how we derive the falling the unit is 1 volt. And what do you mean by if someone asking the potential difference is 1 volt, what it means? Or the potential difference of if 1 volt you understood, then what do you mean by 3 volt? What do you mean by 6 volt? You can easily explain, right? Right? Simple. Same thing only. Okay. Got it? So that's all
Yes, sir.
about the potential difference. Okay, potential difference. What is potential difference? Define it. Then what is equation? When someone asking definition, write the equation as well. Okay, and what is the unit? What is the unit of potential difference?
Volt.
Volt.
Volt. Okay. Now the equipment or the device that is using or that is using to measure electric current is what?
Parameter.
Ammeter, right? Similarly, the device which is used to measure the potential difference between 2 points is voltmeter. Voltmeter. Okay. In a circuit, how we will connect in a circuit? How we will connect ammeter? Series, right? This is series connection. But if I want to measure a potential difference between these 2 points A and B, I will connect a voltmeter parallel to that. Okay. So ammeter is the device which is used to measure the electric current in a circuit, but that will connect in series. This is series. But the device which is using to measure the potential difference between 2 points, that is voltmeter, that voltmeter always connect parallel to a point, parallel to that points where you have to measure the. Got it? What is the device used to measure the potential difference?
Voltmeter.
Voltmeter.
So how it will connect? It will connect
The positive and negative part of the battery.
series or parallel. That is important. Parallel. Parallel. Okay. See what is parallel and what is series that you have to understand. See. Okay. Okay, this is a resistor. What is resistor? We will study. Okay, just think it's something, some device. R1 and R2 are two devices. These two devices are connected in series, one after another. Okay, what is the type of connection here? Series. If I am connecting these two resistance like this, R1, R2, then I am connecting to a battery. This is parallel connection. Here I can say that R1 connected parallel to R2. Okay. So
Okay,
if I
sir.
want to measure a potential difference between these 2 points A and B, okay, I have to connect a voltmeter parallel to that point or across that A and B. Okay. But if I want to measure the electric current in a circuit, how I have to connect? How to connect an ammeter in series. Understood the difference? Series and parallel? All of you? Anumit,
Yes, sir.
Yes, sir.
Faisal?
Yes, sir.
Okay. Now, okay, so that's all about electric current and potential difference. Okay, so electric current is the flow of charge, a flow of electron. So which makes the flow of electron, that is potential. Okay, so these are the relationship between electric current and potential. Okay, so next we will study what is Ohm's law. Okay, so before that, just write down. I will give the notes. We have written the questions only, right? Last class, 12 questions, right?
Yes, sir.
Okay. Uh, okay. So those who are not present, just leave one page. There are 12 questions. Okay, 12 questions, one page. So I am just going to give the answer for all those questions. You can write down. So you have to submit it. I want to see what was the first question. What is the charge of electron, proton, and neutron? Okay, write down the answer quickly. Answer for the first question. All of you need to write it. Okay, front side of your notebook. So, what is the charge of electron, proton, and neutron? This was the question. Write down the answer. The charge of electron is negative. Charge of proton is positive, and neutron doesn't have any charge. It's neutral. Electron negative charge, proton positive, and neutron negative. I'm going to see all like, your notes. You have to submit. I have to see that. Okay. Written? Okay. Next, second question was, what is the unit of charge? What is the unit of charge? The unit of charge is coulomb. The unit of charge is coulomb. It is represented by C, right? The unit of charge is coulomb. 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 coulomb is represented by capital C. That is unit of charge. Then completed, Anuvid. Second question answer. Anuvid,
Yes, sir. Completed.
completed. Third question. Calculate the number of electrons constituting 1 coulomb of charge. Calculate the number of electrons constituting 1 coulomb charge. State the meaning of 1 coulomb charge. Right? This was the third question. How we will calculate the number of electrons? Let me assume. I'm telling the answer. Assume there are n number of small letter n number of electrons. Assume there are small letter n for Noida, n number of electrons present in 1 coulomb charge. Okay. Now, okay. So 1 coulomb charge is equal to n number of electrons. Okay. So what is the question? We have to find out n. That is 1 coulomb divided by E. What is the value of E? E is the, what is E? Charge of an electron. Okay. So I am assuming that there are n number of electrons, right? N number of electrons comes like consisting, which is equal to 1 coulomb charge. So there are n number of electrons. So the total charge will be n into E, right? Charge of an electron is E. So if there are n number of charge, n into E. So that is 1 coulomb I am taking, n into E. So I have to find out n, how many number of electrons. N is equal to 1 coulomb by E. What is the value of E? What is the charge of electron? What is the charge of electron? 1.6 into 10 to the power minus 9. Okay. What you will get? 1 divided by 1.6 into 10 to the power minus 19 is equal to what? It's equal to what? Which is equal to 6 into 10 to the power 18 electrons. So 1 coulomb of charge is equal to the charge of 6 into 10 to the power 18 electrons. Got it? This number, the charge of an electron, 1.6 into 10 to the power minus 19. Okay. But 1 coulomb charge consisting of 6 into 10 to the power 18 number of electrons. Okay. How that comes, that we derive now. Okay. Written. Then Avani, written.
Yes, sir. Yes, sir.
Okay. Now define. Fourth question was define electric current. Define electric current. Write down the answer. Write down the answer. Electric current. Electric current is the amount of charge. Electric current is the amount of charge flowing through a particular area. Flowing through a particular area. Flowing through a particular area in unit time. In unit time. Electric current is the amount of charge flowing through a particular area in unit time. Full stop. In other words, it is the rate of flow of electric charge. In other words, it is the rate of flow of electric charges. Okay. Below that, write down if a net charge q if a net charge q flows across if a net charge q flows across any cross section of a conductor, if a net charge q flows across any cross section of a conductor in time t, time small letter t, then the current I through that cross section, is given by I is equal to q by t. Given by I is equal to q by t. Put it in a box. Current I is equal to written.
Sir,
Hmm.
sir, third question answer only പറയണം.
Third or
Yes, sir.
what is the question? Tell me the question, Lakshminanda. Number of electrons കണ്ടുപിടിച്ചാണോ?
No, sir.
Okay, I will explain that. Others, finish this. I is equal to q by t. You have to write up to this. I is equal to q by t. Finished?
Okay, sir.
Avani, Hazel,
Yes, sir. Yes, sir.
Anuvin, finished?
Yes, sir.
Okay. What was the question?
Sir, what is the meaning of 1 coulomb of charge?
Calculate the number. Okay. State the meaning of 1 coulomb charge. Okay. So that question, okay. I missed that. Okay. So we calculated the number of electrons constituting 1 coulomb charge. That is equal to 6.25 into 10 power 80. Okay. What is the meaning of 1 coulomb charge? It's nothing but same answer only. What is the meaning of 1 coulomb charge? It is the amount of charge of 6 into 10 to the power or 6.25 into 10 to the power 18 electrons. That's it. Just you have to write it because sometimes either they can ask the first question or the second question. So that's why given answer is same only. What is the meaning of 1 coulomb charge? It is the amount of charge of 6 into 6.25 into 10 to the power 18 electrons. Got it? Lakshminanda?
Yes, sir.
Oh. Define electric current. Okay. Question number fifth one. What is the unit of electric current? Write down. What is the unit of electric current?
Ampere.
Ampere. Ampere. A-M-P-E-R-E. Ampere. What is the unit of electric current? Ampere. Sixth question. Define 1 ampere. How we will define 1 ampere? Write down. If, write down. Write down. If 1 coulomb of charge, if 1 coulomb of charge, this one, if 1 coulomb of charge flowing through a cross section, if 1 coulomb of charge flowing through a cross section of a conductor for 1 second, if 1 coulomb of charge flowing through a cross section of a conductor for 1 second, comma, comma, we can say that the amount of current flowing through that cross section, the amount of current flowing through that cross section is 1 ampere. Okay? We can say that the amount of current flowing through that cross section is 1 ampere. If 1 coulomb charge flowing through a cross section of a conductor for 1 second, okay, then we can say that the amount of current flowing through that cross section is 1 ampere. We can write 1 ampere is equal to 1 coulomb by 1 second. Okay. After writing the statement, write down this also. 1 ampere is equal to 1 coulomb by 1 second. What is the next question? Convert 1 milliampere and 1 microampere into ampere.
Sir, 1 ampere is equal to
1 milliampere is equal to how many ampere? How will write?
sir the sixth question.
Sixth question we written, right? Define 1 ampere. ഒന്നിൽ ഇപ്പൊ എഴുതിയേ
Sir, 1 ampere is equal to 1 coulomb by
1 coulomb by 1 second അല്ലേ അതിലെ definition പറയുന്നത് if 1 coulomb of
yes,
charge
sir.
flowing in 1 second time, so 1 coulomb by 1 second.
Okay,
1
sir.
ampere is equal to 1 coulomb. Seventh question answer. Convert 1 milliampere and 1 microampere into ampere. What is 1 milliampere? 1 milliampere is equal to what, Hazel?
Sir, 10 raised to negative 3 ampere.
Yes.
Yeah.
1 milliampere is equal to 10 raised 1 into 10 to the power minus 3. 10 raised to minus 3 ampere. Similarly, 1 microampere is equal to what, Anu? 1 microampere is equal to what, Anuvind?
Sir, I don't know.
Hmm?
Sir, don't know.
You don't know. Who knows?
Sir,
Tell me.
10 raised to minus 6 ampere.
Yes. 1 into 10 to the power minus 6 ampere. 1 into 10 to the power minus 6. Milli is 10 to the power minus 3. Micro is 10 to the power minus 6. Nano is 10 to the power minus 9. Okay. Milli, micro and nano. Question number 8. Name the device used to measure electric current in a circuit. Also mention how this device need to connect in a circuit to measure the electric current. What is the answer? Question you already written. Those who are not written, just leave the space. What is the device?
Ammeter.
Ammeter. And how we have to connect the device in a circuit?
Series.
In series. In series. Next question. What is electric circuit? Explain the diagram. Okay. Ninth question is what is electric circuit? Explain with the diagram. Write down this. Electric circuit is those which consist of a cell. Electric circuit is those which consist of a cell, comma bulb, comma ammeter, and a key or switch bracket. Electric circuit is those which consist of a cell, comma bulb, comma ammeter, and a key or switch. These are interconnected using a conductor, in general using a copper. Electric circuit is those which consist of a cell, bulb, ammeter, switch, etc. These are interconnected using a conductor, in general using a copper. Okay, draw this picture. After writing up to this statement, draw this picture. The last two statements we can write last after drawing this picture. You can write this is cell or battery. Okay, this is bulb, this is ammeter, this is switch. Okay, and the I is the current, electric direction. Done. Done.
Yes, sir.
Lakshminanda, finished.
Yes, sir.
Okay. Next question. What is the importance or function of a battery in a electric circuit? What is the importance or function of a battery in an electric circuit? What is important?
Creates potential difference.
Yes. Battery creates a potential difference, okay, which moves the electrons from one point to another. Battery creates the potential difference which moves the electrons from one point to another. Battery or cell creates the potential difference, okay, which moves the electrons from one point to another. Okay. Next question, 11th question. How will be the direction of electron flow in a circuit? What will be the direction?
Negative to positive.
Negative terminal to positive terminal. The direction of electron flow. Okay, it's not current. The direction of electron flow in a circuit is from the negative terminal of the battery to the positive terminal. Negative terminal of the battery to the positive.
Sir, can you once again repeat the 10th question?
What is the importance or function of a battery? Battery is giving the potential difference, right? So, to provide the potential difference across 2 points and which moves the electrons from one point to another in the circuit.
Okay, sir.
Battery provides potential or creates potential difference which moves the electrons from one point to another. 12th question. What is the conventional direction of electric current in a circuit? Hazel. What is the conventional direction of electric current in a circuit?
Positive to negative.
Hazel.
Sir, positive term to
Positive
negative
terminal
term.
to negative terminal. Okay. So up to this, I think you already have written the question. Okay. Write on next question. 13th one. 13th one. Can you see this screen? 13th one. A 600 coulomb of charge, a 600 coulomb of charge flows through a filament. A 600 coulomb of charge flows through a filament of electric bulb for 10 minutes. A 600 coulomb of charge flows through a filament of electric bulb for 10 minutes. Find the amount of current flows through the circuit. Find the amount of current flows through the circuit. Find out. First you write down the question and write down what are the things given. You understood the concept what is electric current, then you will write it. Doing? Anybody got the answer?
So 60 amperes.
I know you will get a 60 ampere only. What is current? Current is what? Electric current I is what? It is the amount of charge flowing through a cross section in unit time. In unit time is what? 1 second. So no. Anyway,
Yes, sir.
so you have to find out the amount of charge flowing in 1 second. Here time is given what? 10 minutes. Okay. How did you get the answer? 10 ampere. Tell me. I is equal to Q by T.
So 60 ampere.
600 divided, sorry, 600 divided by 10, right? I know you will do the mistake. This is wrong. How many of you done like this? Tell me frankly. See, first of all, see if you're not able to do, if someone is doing quickly, that is not your problem. Okay, each person have their own capability. If you are not able to do it, please stop me. Clarify and move again. Okay, got it, Devaganga?
Yes, sir, I got it.
Okay, Avni.
Yes, sir. Understood.
You made any mistake or first time itself you got 1 ampere?
No, sir, I didn't write it.
I didn't get you.
Sir, I didn't convert into seconds.
You also got 60 ampere, right?
Yes, sir.
Right. What about Hazel?
Sir, I converted it. I got the correct answer.
You converted, right?
Yes, sir.
Lakshminanda,
Yes, sir.
you also converted?
Yes, sir.
Okay. See, no problem. See, once you made the mistake and you understood, oh, this is a mistake, okay, and how to avoid that mistake in future, that's good. That's fine. Now here you understood, right? 10 minutes. So that's the importance of definition. Definition you have to understand properly. What is current? It is the amount of charge flowing through any cross section in unit time. It means in 1 second. So that's why we're converting into seconds. Okay. So we can stop today. I will give some 2 or 3 homeworks. That's it. Okay. I'm not giving much homeworks. We will discuss all the questions in the class, all the additional questions. So, but 2 or 3 homeworks I will give. I'm not disturbing you much. Okay. We will stop today.